Welcome back, students. As you know, in previous lectures, we were doing linear equations in two variables. I told you how to form these equations and then how to solve them graphically, how to draw the graph of these equations. Now, today, I'll tell you few word problems based on linear equations in two variables. Now you will see how to form the equations and how to solve them. So we'll start with the question number 1 of the day. The force exerted to pull a cart is directly proportional to the acceleration produced in the body. Now express this statement as a linear equation in two variables and draw the graph. Draw the graph taking constant mass equal to 6 kg. Read from the graph the force required when the acceleration produced is, first part, 5 meter per second square, second part 6 meter per second square. Now first of all, let the acceleration be x and force be y. Now the question says that the force is directly proportional to the acceleration. So that means y is directly proportional to x. Now whenever you remove the proportionality sign, you have to introduce a constant of proportionality. So here, suppose The constant of proportionality is k. So this is the linear equation in two variables where x is the acceleration produced, y is the force exerted, and k is the constant of proportionality. Now we know that this constant of proportionality is actually the mass of the body on which the force is being applied. So they are saying that the mass we have to take as 6 kg, so y is equal to 6x. That will be the linear equation when the mass is given 6 kg. Now we have to draw the graph of this linear equation in two variables. I told you whenever you have to draw the graph, first you make a table like this. Now when x is 0, 6 into 0, 0, so y is also 0. When x is 1, y is 6 into 1, y is 6. And when x is say 5, then y will be 6 into 5, 30. Okay, so we have got 3 points to plot. Now what we do, as all the values are in positive, so we need more space on the positive side. Now this is 5, 10, 15, 20, 25, 30, 35. You have to take the scale accordingly because you can see we have to plot up to 30 in y. So that is why we have to take this scale. And this side also 5, 10, 15, 20, 25, or you can do one thing, here you write 1, 2, 3, 4, 5, 6, 7, so on. Now you have to write the scale also. Scale on x-axis 1 centimeter is equal to 1 unit. On y-axis 1 centimeter is equal to 5 units. You can see on x-axis 1 centimeter is 1 unit, whereas on y-axis 1 centimeter is 5 units. Now when x is 0, y is 0, so there is the point 0, 0. Okay. When x is 1, y is 6, so it is almost here. When x is 1, y is 6. When x is 5, y is 30. When x is 5, y is 30, almost here. Okay. This is 1, 6 and this is 5, 30. Now when you join these points, you will see you will get a straight line because it is a linear equation. So whenever you join these points, you will get a straight line like this. Okay. So that is the graph. And now they are saying when the acceleration, that means the value of x is 5, what would be the value of force, that is value of acceleration means value of x. When the value of x is 5, what would be the value of y, that is the force. So we have already drawn over here. You can see when x is 5, y is 30. And the second part, when x is 6,
And if you draw a line parallel to this line, when you draw the graph, accurate graph on the graph paper, you will see this is nothing but 36. So when x is equal to 5, y is equal to 30, when x is equal to 6, y is equal to 36. Okay, if x is in meter per second square and the mass is in kg as it is given, so all of you know that value of y will be kg meter per second square or Newton. Actually it is nothing but the force, so all of you know that unit of force is Newton. Okay, now the next question. If the work done by a body on application of a constant force is directly proportional to the distance traveled by the body express this in the form of an equation in two variables and draw the graph taking force as 5 units. Also read from the graph. The work done. Also read from the graph the work done when the distance traveled is First part 2 units and second part 4 units. So now let the work done, let the distance traveled be x and the work done be y. Now it is given that the work done is directly proportional to the distance traveled. So y is directly proportional to x. Now if you remove the proportionality sign, you have to introduce a constant of proportionality. Now that constant of proportionality, let it be k. So y is equal to kx. That is the linear equation in two variables. Now we know that this k is actually the force applied on the body, which is given as 5 units here. So you put k is equal to 5, then it is y is equal to 5x. So the equation, the linear equation in two variable, in this case will be y is equal to 5x. Now we have to draw the graph of this y is equal to 5x. So for that, first of all you draw a table like this. When x is 1, if we put x into 1 here, y is equal to 5. When x is 2, then y is equal to 10. When x is 3, y will be equal to 15. And when x is 4, y will be equal to 20. Although 3 points are sufficient, we have taken 4 here. And now when you draw the graph, so we'll draw the graph in the next frame. We'll draw the graph here. One, two, three, four, 5. Five, 10, 15, 20, 25. Scale on x-axis 1 centimeter is equal to 1 unit. On y-axis 1 centimeter is equal to scale on x-axis 1 centimeter is equal to 1 unit. On y-axis 1 centimeter is equal to 5 units. You can see here 1 centimeter is equal to 5 units. Okay. Now what we do, when x is 1, y is 5. When x is 2, y is 10. When x is 3, y is 15. When x is 4, y is 20. That's all. Now if you draw them, if you join them, you can see you will get a straight line. That means because it is a linear equation, so you can see we are getting a straight line. And now when the distance traveled is 2 units, means x is 2. This is the distance traveled. This is the distance traveled on the x-axis, and this is the work done. Like this. Now, when x is 2, you can see when x is 2, y is 10, and when x is 4, y is 20. So, when distance traveled is 2 units, then work done is 10 units. Okay, when distance traveled is 2 units, the work done is 10 units. And your second answer, when distance traveled is 4 units, then the work done is 20 units. Okay, work done is 20 units. You know that distance traveled usually we take in meters, and the force which is here, which is given 5 units, actually it is taken in newtons. Then the work done we get in joules, but they have used units here, so that is why when the distance traveled, you can, once you draw the graph, now for any distance traveled you can calculate the work done. As you can see here, when the distance traveled is 0, the work done is also 0. When the distance traveled is 1, work done 5, 2, work done 10. When the distance traveled is 3 units, the work done will be 15, and so on. So once the graph is formed, you can easily calculate the value of y with any given value of x. Clear? So in the next class we will do few more questions based on this word problems that we will do in the next class. Okay.